Hello friends, my topic is digital logic gates. Let's know what is logic gate. A logic gate is an electronic device which performs Boolean functions and logical operations. Mainly the logical operations are performed on the binary inputs and produces the binary output. Here there are some important notes on the logic gate. A logic gate which transfers the information and controls the transmission of input pulses, and it is also called as the building block of the electronic circuits. In digital electronics, a gate is a logic gate circuit which has two or more inputs and only one output. Here the inputs and the outputs are in the form of zeros and ones, and they may be called as off and on, up and down, closed and open, true and false. Here the state 1 represents the presence of a signal, while the state 0 represents its absence. Now let's note the types of the logic gates. There are two types of logic gates: basic logic gates which are NOT and OR, and the universal logic gates NAND and NOR. Here is the NOT gate. NOT gate is one of the basic digital logic gate. A NOT circuit has one input and one output. It works as inverting the polarity of a pulse applied to it. The Boolean expression of NOT gate is y is equal to a bar or a dash. Here the dash or bar represents the negation. Here is the symbol of the NOT gate, in which a is the input and z is equal to a bar is the output. Next there is a circuit diagram in which a is the input, R and R2 are the resistors, T1 is the transistor. Here the transistor works as an amplifier and switch which strengthen the input signal, and Q is equal to Q bar is the output. Let's see the truth table, in which input is 1, then the output is 0, and when the input is 0, output is 1, which is negating the input. Here in the circuit diagram, in the transistor, the arrow symbol indicates the emitter state, which is grounded. The opposite of the emitter is known as the collector. Now the output is taken from that side when no signal is applied at the input, that is A is equal to 0. Then the transistor will be in the cutoff state and the output is high, that is A bar is equal to 1 volt. On the other hand, when A is equal to 1 volt, the signal is passed to the transistor, which conducts and draws maximum collector current, as whole of VCC drops across R, and the output Y is equal to 0 volt. Thus in a NOT circuit, output is not present when the input signal is applied. Thus the output is in the inverse of the input. Now let's go into the OR gate. OR gate, which is also one of the basic digital logic gate. An OR circuit has two inputs and one output. If any one input is 1, then the output is also 1, or else the output is 0. Here is the Boolean expression of OR gate, is known as y is equal to a plus b. Here the plus indicates OR. We can call it as A or B. Here A and B are two inputs and A plus B is the output. Let's see the truth table. Here two inputs are performed in 4 conditions. A and B are the inputs, and 0 in the first case 0 0, which has the output as 0, and next case A is 0 and B is 1, then the output is 1, and in the next case A is equal to 1, B is 0, then the output is 1, and in the last case both the inputs are 1, then the output is also 1. Here is the symbol of OR gate. A and B are the inputs and y is equal to A plus B is the output, and there is a circuit diagram in which X and Y are the inputs. There is two diodes, R is the resistor and Z is equal to X plus Y is the output. There are 4 cases to know how OR gate works. In the first case, the input A is equal to 0 and B is equal to 0 volt. There is no voltage is applied. Hence none of the diodes conducts and the output is Y is equal to 0 volt. This is seen in the truth table. In the second case, the input A is equal to 0 volt and B is equal to 1 volt. Here for the first diode, no signal is passed, and to the second diode, positive pulse is given. Hence the diode D2 is forward biased and conducts. Then the output Y is equal to 1 volt. In the next case, input A is equal to 1 volt and B is equal to 0 volt. Now for the first diode, the voltage is given, and for the second diode, no signal is passed. Hence the diode D1 is forward biased and conducts. Then the output is Y is equal to 1 volt. In the fourth case, both the inputs A is equal to 1 volt and B is equal to 1 volt. Both the diodes are forward biased and conducts. Then the output Y is equal to 1 volt. These results are shown in the truth table. Next, we'll go into the AND gate. An AND gate is also the basic digital logic gate. An AND gate circuit has two inputs and one output. If any one input is 0, the output is also 0, or else it is 1. Here is the Boolean expression, which is Y is equal to A dot B. Here the dot indicates and it is called as A and B. Here is the truth table. A and B are the inputs. Y is equal to A dot B is the output. In the first case, A is 0 and B is 0, then the output Y is equal to 0. And in the second case, A is 0 and B is 1, and then Y is equal to 0. And in the third case, A is 1 and B is 0, then output is 0. In the last case, both the inputs are 1, then the output is 1. Here is the symbol of the AND gate, in which A and B are the inputs and Y is equal to A dot B is the output. And there is a circuit diagram in which A and B are the inputs. There are two diodes, and R is the resistor, and VCC is the voltage, and Y is equal to A dot B is the output. There are four possibilities in which the input voltages may appear. In the first case, when both the inputs A is equal to 0 volt and B is equal to 0 volt, the inputs are short circuited to the ground, then the Y is equal to 0 volt. When in the second case, when A is equal to 0 volt and B is equal to 1 volt, then the diode D1 conducts and the output is short circuited to the ground through the diode. Hence Y is equal to 0 volt. Here we are giving B is equal to 1 volt, but the D1 is conducting because the diodes are reverse connected. In the third case, when A is equal to 1 volt and B is equal to 0 volt, then here because of diodes are reverse connected, here D2 is conducting and the output is short circuited to the ground. Hence the Y is equal to 0 volt. When the both A is equal to 1 volt and B is equal to 1 volt, neither D1 nor D2 conducts, no current flows through R, and Y is equal to 1 volt, which is given from the voltage. Thank you.